Poznan University of Technology.
Hello, everyone. We still have a couple of minutes, so maybe I'll ask a bunch of questions. As I understand, you're PhD students, right? But you're not from an ICT background, is that right? So if you wouldn't mind sharing, could you tell me what your major is, starting with you? Okay, so material sciences, chemistry, stuff like that a bit? And physics. Okay. Okay. How about you? Architecture, okay. 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 Robotics. I know you. Okay.
Me, environmental engineering.
Okay.
Civil engineering.
Civil engineering.
Management engineering.
Management. Okay.
Civil engineering. Management.
Management. Okay. Okay. So environmental engineering is like eco buildings, stuff like that. Okay. Great. So I guess I'll start. So I already know who you are in terms of what you're learning. My name is Dariusz Brzezinski, and I'll be your host for today's episode of Introduction to Artificial Intelligence. And I'm going to do this course, well, it says introduction, as a like nice and smooth introduction, but aimed at people that are going to be mostly users, or hopefully after these lectures, power users of AI. Okay, so I'll try to stay away from all those squiggly math and stuff like that wherever possible, rather give you the intuition. And we're going to do this in parts. The first part, I want to show you applications, and I hope you'll find applications or inspirations for how you could use AI in your problem fields. Okay, so probably you'll know some of the stuff, okay, but maybe some of it will be new and inspiring. The second part will be theory. So I'm going to show you something without saying how it works in details. And in the second lecture, I'm going to tell you, well, what is the general intuition behind some of the approaches to actually do those things. And the third part is going to be a workshop where actually I hope you're going to come up with ideas in how to use AI in your PhD studies or related scientific problems. And together, we're going to see if that's possible and what ingredients you actually need to do that. So this is basically what I said. We're going to start with applications. We're going to have separate lectures on images and text, but I'll now knowing what you do, I'll try to also spice this with some applications for your particular things you want to do. So first of all, a bit of terminology. I'll also set myself up over here. There are a lot of terms, okay? And we're using the term artificial intelligence. If you know somebody really old, they might use terms like knowledge discovery from data. You might know people saying something about data mining. Younger people know something like data science. There was a hype for business intelligence. Those are all terms that are related. And here at university, we would say, oh, this is slightly different because this one snores at night, this one sneezes really loud. But basically, for your purposes as users, it's basically the same. Okay, so if you hear me saying machine learning, data science, statistics, AI, it's basically the same for our purposes here today. But that being said, I'm a person that works in machine learning. Okay, so when I try to sell something, I'm going to call it AI, right? Because machine learning is kind of, this is a simplification, part of AI. Nevertheless, I deal with machine learning, which is a subfield of computer science, mathematics, artificial intelligence, dedicated to the, let's say, brains of artificial intelligence. Something that takes in data and based on data makes some predictions, okay? And you've been using AI before it was hip. Whenever you go into Google, Google magically selects pages that you were searching for. And if you have friends, this is an if because I'm a computer scientist. Computer scientists don't have friends. they live sad lives in universities. So if you have friends, I heard, right, they get different results at Google, right? Because this is all personalized, because there's an AI algorithm that actually knows your preferences, knows your history, and recommends stuff. If you're buying stuff online, this is very similar. Face recognition, opening your phone or computer with that, that's also AI. That's been for years. Spam filtering is something so obvious we don't really know. This is a simple algorithm that tries to classify, as we will say, good things, ham, versus not so good things, spam. Credit risk assessment, if you go to the bank, for years now, many banks have programs that try to filter out the most obvious cases in terms of DB doesn't get a loan, you get a loan. Okay, so we're going to go back to this, and you probably had some of it yesterday, right? I must tell you, I must confess, right? I was walking down there, and I took a peek at the invited lecture. And I saw you had some perceptrons, stuff like that. So you probably heard some of it. But me being me, I have to do it my way. So we're going to talk about machine learning. There are two flavors of machine learning. One is unsupervised, and one is supervised. Unsupervised machine learning is machine learning without a teacher. So you basically have some data. Let's say this is marketing data or management data. And we have clients, people in general. We know their age and their salary. And we might be interested in selling products to those people. And we could, of course, spray and pray, right? Send a bunch of marketing things to people and just hope it's right for them. But if we knew something more about them, let's say their demographics or their preferences in any way, we could have targeted campaigns to different groups. But how many groups and what are those groups? Are those groups based on age or gender or whatever, right? We can ask a clustering algorithm to cluster, group similar people into groups, and then maybe we could have a campaign. So basically, we just give the data. We say, look for patterns, look for groups, and it gives you groups, okay? So based on chemical properties, right, how can I group these materials, right? Do they have similar, let's say, point groups or space groups if they're in 3D, right? Or we already talked about clients, right? Can we group in architecture, let's say, building plots in terms of their properties, right? It's not just their size or shape. They can be close to water, to roads, schools, stuff like that. Another nice way of unsupervised learning is association mining. We're going to have it during the second lecture, but if you're going into a shop, right, you're usually buying stuff, right? And after that, you pay for that stuff and you get a receipt. And on that receipt, you basically have, you bought diapers, you bought beer, right? And you bought, let's say, water. And if you have all those receipts, you might find that some things co-occur or form associations. So basically, this is the toy example in this field. If diapers, then beer, right? Think about it. Think about it, right? If beer, then let's say cashew nuts or crisps, right? Makes sense, right? But if you have millions of products, right, and tens of thousands of clients, it might be hard to spot those associations just like that. And you have an algorithm when you give a lot of receipts, and it gives you associations, things that co-occur together. Maybe somebody will help those people. They look stranded. Okay, so the second flavor of machine learning, which you probably heard about, is supervised learning. This is learning with a teacher. So not only do we give data, but we also give some tuition. We give some ground truth. So a common example would be classification, where once again we might have our customers. We know their age and their salary, but we know one more thing. Those are historical clients, and we know which one of them positively reacted to our marketing campaign and which ones did not positively react. That's negatively reacted. Okay? And we have that historical data. We call that labeled training examples. So this is basically data. We call it examples. And it's labeled because we know something more about them than just their attributes. We know their target attributes. Here we know whether they reacted to the campaign or not. Now, what we will try to do, right, and what you will learn sometime Friday, right, it's just a few clicks of a button, we can create something called a prediction model. A prediction model is a box where you put in data, right, and it gives you a prediction. So if you have this magical box called a prediction model, it basically knows how to distinguish between positive and negative clients, positive and negative classes. So I don't know if it's visible, but apart from that historical part of the data, the green and red, we have this gray guy over here. And we're not sure how he will react because we did not send him the campaign. This is a new client. And using historical data, we want to say, OK, should I send the campaign to him or not? And if you have a prediction model, it sometimes can be depicted as this kind of decision boundary. It will tell you on which side of the boundary it is. And here you can kind of see he's in the red zone, right? Probably better not to send the campaign to him. This is new data. Now I'm going to do a trick, okay? Because you all have different fields, okay? And I've heard about some of them, right? So I'll try to, throw some examples saying, oh, I know architecture or material science or stuff like that. But the true power of machine learning is that it's basically a form of automation. And for me, as a machine learning expert, right, if I'm working on general models, I don't really care what the data is. So these could be patients, these could be people, marketing specialists, these could be building plots. This could be data from flow cytometry, right? These could be cells. And I could be analyzing the cell size, right? Front scattering, side scattering, the granularity of the cells. And I could decide whether this patient has leukemia or not based on his cell data. So the trick is, right, I'm going to show you a bunch of examples. And you have to just squint your eyes and ignore this is, not your field and imagine you can use it for your purposes. Okay? So that's basically your task. Before we go further, right, you'll lose attention at some point. I talk too much, right? So this is like the last moment when I have your attention. So there are 3 rules I would like to sell to you. There's a really nice Caltech online learning course and a book by Professor Abu Mustafa, and he does a great job explaining machine learning on a, let's say, theoretical level. But he also gives some good advice when it works and when it doesn't. And there are 3 basic rules. You might have heard them under the term garbage in, garbage out, but there's like a better set of rules. If you want to use machine learning, there needs to be a pattern in the studied problem, right? That's not always the case. If you go to the casino, right, and want machine learning to win, that won't work because it's random, right? The same goes for long-term stock trading, right? It's really hard to predict because it's very random and dependent on things you don't have information about. Short-term trading, why not, right? Swing trading, 5 days, meh. Okay, but you see the point, right? There might be processes in your field that have a lot of randomness, right? Or you're not measuring something. So you might not always have the pattern. But if you think there is a pattern, let's go to step 2. You cannot model the pattern mathematically. So I won't do this, right? But I could take this pen and throw it down, right? I could do it 1,000 times, measure how long it takes to fall down, and I have a machine learning problem, right? If the pen is this high, how long will it take to fall down? This is a regression problem. But I won't do that because it has been already modeled mathematically. And it's safer and it has a better interpretation. Just don't, right? But there's an asterisk over here. That's because sometimes you can model the problem mathematically, but it takes forever, right? So maybe a good example would be, let's say we're doing material science or structural biology or chemistry, right? We want to understand how a compound behaves, right? And it's a new compound. We don't have a crystallographic structure of it. We might want to do stuff like quantum mechanics. And it takes a long time to calculate, based on physics and mathematics, what are the energetic optimal places for a given compound? What are its common conformations, right? So it's a thing you actually have a lot of physics to work with, but it takes forever. So we have a lot of stuff that does it for you, maybe not as well, but faster using machine learning. But if you have a mathematical model, that might not be the best problem. And the last thing, we have data on the problem. How much is a different issue, but sometimes we don't have data, or we don't have the right data, or it's very expensive. That also might be a blocker. So before you dive into the AI hype, 3 rules, right, to keep you grounded. Okay, so as I've already mentioned, right, I'm going to give you a lot of examples. We're going to do fun stuff over here just to show you diversity. But your goal is to see how you could apply it to your problems. By the way, if you have any questions, right, raise your hand. I might answer your question or not, but let's pretend. Okay, so first things first, images, right? This is visual. This should be simple. We're going to use machine learning to do stuff on images. So it's good to understand what an image actually is. So an image, if it's black or white, it's actually a matrix, right? A table of numbers. If you would open Excel, right, and put in a bunch of numbers, usually between 0 and 255, and you would change the shade of gray depending on the number, right? High number would be light, low number would be dark. You would have something like this, okay? And actually, let's try to do something like that, right? I really like this page that shows you, you might not see it, but here you have numbers, and when I hover over a number on the left, it shows you the pixel on the right. Over here, we can see it's a face. When it's big, it doesn't look as impressive, but those are basically pixels. Now, since these are numbers, right, some crazy person thought, okay, let's do operations on those numbers. They call those kernels, right? And if you move that kernel, a kernel is basically, I take this pixel, see, right? It's 234. I multiply it by 0, right? I take this pixel, do something else, and so on and so on. And if I do this operation on this kernel, on this set, right, of pixels, I get this image. And look, what we did by simple multiplication is we sharpened the image. Okay, maybe we can look at an outline. Maybe we can blur it, right? And people have been for years thinking of kernels that modify an image, right? And those are basically like filters, but Stone Age filters, right? Instagram filters, Stone Age. So this is all really nice, right? An image is just a bunch of numbers, and you can do operations on them. And if you do that operation on this set of pixels, then this set of pixels, and so on, and you move this mask, you will get these pixels over here, right? Is that understood? Okay, so now you basically know what are convolutional neural networks. It's basically a neural network that comes up with these numbers. You might have heard they're called weights or something like that. But basically, you take an image, and if I gave these numbers, right, to an algorithm that takes these set of pictures and give those, I would have outline, blur, and so on. But what if an algorithm would try to come up with those kernels on their own? And this is what convolutional neural networks actually do, right? They take a bunch of pixels, and they come up with funny kernels, right? Then they see whether this kernel helped them differentiate between some set of images and a different set of images. If it didn't work, improve, and so on and so on. And after millions of pictures, you have a network that actually has different transformation or reacts differently to different sets of pixels. On the first layers, it works on simple patterns like color, basic shapes. Then you have texture. Then you have things like eyes, noses, beaks, wheels, and so on. But basically, it's a bunch of operations of numbers. one more trick before we go into the applications. You now know images are just a bunch of numbers. Actually, there's a common trick, right? You also probably have numbers. And people, when they don't know what to do, they convert their numbers into an image and use the same algorithm for other stuff. Example, you have a DNA sequence, okay? It's very long. But if I just wrap it around in a 200 by 200, right, or something like that, and I summarize, it's basically a matrix of numbers, right? And I can give it to this algorithm to look for features, right? Or you have, let's say, a sequence of not DNA, but amino acids, right? Proteins or stuff like that, right? You have a SMILES strings for chemistry or stuff like that, or a SMARTS for reactions in chemistry. Think about it, right? There's one more trick that really works well. People have spent millions of images in a competition called ImageNet and trained classifiers to differentiate between tanks, dogs, cats, people, and stuff like that. But you want to predict, for example, whether this building plot has a pond, right? Or whether this satellite image has, I don't know, clouds of a certain type. So what you do, you take what other people created, right? And that network already knows how to differentiate colors, shape, and stuff like that. The thing it doesn't do right is it predicts tanks and dogs instead of clouds. So what you do something called transfer learning. You steal their model, right? You change the input from, let's say, regular image to diffraction images, and you change the classes from dog and cat into, let's say, diffuse scattering, ice rings, or other artifacts, okay? You have to change part of the network and retrain it on your data. This is good because this network is already pretty powerful, and it was trained on millions of examples. And you have something, let's say, like 200 examples. So if you would want to learn a model from scratch, that probably wouldn't work as well. But with transfer learning, right, you get most of the heavy lifting done, and you just train the classifier at the end over here to do the prediction. So transfer learning, very good. Okay, apart from, let's say, recognizing faces or stuff like that, you could also decide where something actually is, right? So you go around with your phone, right, and it detects objects for you, right? This basically is something like running a classifier on different parts of the image and then deciding where's the bounding box. So this is also really nice if you want to detect something. It's just a step away from recognizing something. Here's a really nice, I believe, Japanese startup, which have a nice idea. Okay, images, faces, haha, very nice. They have this idea when you have a big place with a lot of machines, many of those machines have these kind of gauges, right, which are analog, right? We're talking about industry 4 point something, right? But we have a lot of big old machines that have been working for 20 or more years. We don't want to change them just because we want them to work on Bluetooth, right? So what they do, they actually put in a camera which has a battery that lasts for a year or two, right? They put it next to the gauge. It makes a picture every minute, every hour, or whatever, right? It looks at the gauge, it recognizes where it is, and changes the analog position into a number. And then your analog factory can be made industry 4 point something, right? So this is a good idea of making something digital through recognizing images. Of course, when we go into medicine and stuff like that, people have been counting cells. If you have chemical or biological, let's say, high throughput screening, you have stuff like cell painting, which is wonderful, where you have cells stained with different dyes, and you have 4 basically usually different colors, where let's say the nucleus is blue, the Golgi apparatus is green, and stuff like that. And you can see how a cell behaves depending what you put on it, right? You can see whether something is toxic, whether it makes the cells smaller, bigger, where it affects the nucleus, or amazing, right? But big images, a lot of data, this is a place where AI could be useful. Of course, eye scans, X-rays, MRI scans, stuff like that. You could do the same thing with objects, right? we have a really nice team of people working with LiDAR scanners and place recognition. You go through a car, you have a LiDAR, which is basically a light radar, and you have a point of clouds detecting stuff, right? You can detect 3D objects, quantify their shapes and stuff like that. Also very interesting. Now, something which is so 2022, right, is image generation, right? I've generated images here as well, right? I didn't draw these, right? This is what we usually use generated images for, making a nice, let's say, backsplash for your presentation, which is, of course, nice. But the general idea of diffusion models, which is probably the most popular way of generating images, is that they basically had an image and they wanted to fix images. So let's say you have an old image, you scan it, it's not perfect, you have some sort of salt and pepper noise, right, some sand or something like that. It's not the crisp image you want. So they trained a model by saying, okay, this is the perfect image, now we're adding random noise, see if you can fix the image. And it fixed the images. But then they went a bit too far, right? They added more noise, right, and more noise, and basically now we can generate images from noise. You have to add context and say, well, this is noise plus there's a dog in there. But basically, this is what they did. Now, maybe you have a similar idea where you want to generate something. So diffusion models work like you know what you want to generate, you perturb it, you add noise to it, and see if the classifier, if the model can learn to generate something from noise. And of course, images are nice, but you can do this with sound, you can do this with satellite images, you can do this with weather reports, a lot of stuff. Okay, so generative AI, of course, is a nice quirky thing, but it can be used also for very specialized things like generating additional examples, right? don't have a lot of, let's say, patient data. I don't have a lot of things I need for my purposes. Maybe I can generate them. It's not perfect, but it might be better than nothing. Yeah, so generated images already won contests, right? If you're learning architecture, right? You might have also used Midjourney for inspiration, right? I actually know there was a student course where they were allowed and invited to use AI to design a tram of the future. And they Googled for inspiration, then they generated for inspiration, and they were interested what the students did. So the project that one was fully AI generated. But this really helps, right? I won't do this, right, because I don't have my phone prepared to share the screen, but there are apps like Remodel AI, where you take a picture of your house and you say, change the floor, right? Or change the staircase, or change the entire image into, let's say, Japanese styled or colonial style or something like that. So for architects, image generation with context is really nice, at least for inspiration, for starting off and stuff like that. You can clean up pictures. You now have virtual influencers, which you might have heard about, right? Instead of a person creating content, you have content creating content, and they have a lot of actually followers. You could have something like make a video, right? You want to send a thank you message, and you want to, just like with serial mails, right? You used to have like Excel, name, surname, and email, and you said a personalized email to everybody. Now you can send a personalized phone message or a personalized video. So you stand in front of the camera, right? You say something, and then the AI changes, your words, your voice, so you're giving a personalized message or thank you message to Robert. Thank you, Robert, for supporting our company, right? But it's actually generated and stuff like that. There is really nice stuff like NVIDIA Canvas. Maybe I'll show it to you. I really like this idea. NVIDIA Canvas was something that was given with some NVIDIA cards. And the basic idea is that you can draw something, right, with, let's say, paint, and it generates that image based on it. You have also free versions of sketching where you just doodle, draw a cat, and it generates a cat for you. And if you really want that cat to be, hanging on one leg from a tree or something like that, if you really want to compose that dramatic scene, right, You can draw it and generate it, right? There's also stuff like in-painting and out-painting. You have an image. This is a very popular tool. You have a lot of Photoshop now also uses this. Let's say you have an image, right? And it's a Game of Thrones episode. And you have a Starbucks coffee mug over here. And it's like, oh, no. Now we have to invite the whole bunch and redirect the whole scene. No, you don't. You just click. It disappears, right? Usually, you would have to remove that part and kind of smudge it or stuff like that. But now with in-painting, you remove stuff and you generate the missing part. And that's really nice. This is also nice for architects, right? Oh, I really don't like this piece of furniture. You remove it and then you in-paint it. And you put a different piece of furniture, a credenza, a beautiful credenza that matches the floor, right? You can just do it. So this is really nice set of ideas that you could also have tools where you have a bit more control. It's not just like create me a funny image of a cat. Okay, so copyrights, let's not talk about that. But there are ideas like, I don't remember which company, but they actually used the creator's data to train the model, and now when you generate an image, a stock image on that side, the creators get part of the profit, okay? So there are, in some cases, I think, fair ways around it. In other cases, maybe let's not talk about it. There used to be a job offering for prompt engineers, so people that think of prompts, so keywords that generate stuff for you, right? It's not really that needed, it appears, right? Because you can have AI generate a prompt for you, which you give into another AI. But do know that there are special websites where if you don't want to waste time, you could actually buy a prompt, right? So probably the most popular is prompt-based. There's another one which is basically free. If you want something in a specific style, right, instead of spending an hour changing the prompt and something like that, you can buy it. And it's something like $1, $2, $3, or $5. So me spending 1 hour experimenting, or me spending $2 to have it out of the box for an advertisement, for something like that, it's actually not bad, right? And they tell you what to write, right? And you just change it. So in the case of my presentation, right? In the case of my presentation, we'll go a bit further. You will see all those images are in a similar style because I bought a prompt just to see if it works. It works, okay? Okay, so, Lexica AI is the other product. So there are a lot of products that actually do stuff for you. These are some of the, let's say, early adopters. But those slowly will die out, right? And Google, Microsoft, Meta are actually, buying the good company, integrating it into their products, right? So don't get too attached to those. I maybe would like to, mention one more thing, image upscaling. Okay, this is really nice. Whenever you generate an image or have an image and it's all blurry and you're like, this is nice, but this is too small for my, I don't know, poster or something like that, there are paid and free upscaling algorithms which basically increase the resolution. So I vividly remember, right, when I was studying computer science, we would watch with our friends something like CSI, right? And they always have to zoom in on the plates. And we were like, yeah, right. They're imagining pixels. Good. Yeah, it happens now, right? It's imagining them, so it's not, super resolution. But it basically works like CSI. Yeah. Okay, so you've seen a lot of applications. Let's see how some of them works. Let's start with the first one. This is Teachable Machine. I like to use this one because it shows you, let's say, how to train a model, right? So we're going to train an image recognition model. So we're going to differentiate between the good guys and the bad guys, okay? So I'm the bad guy, okay? And we need training examples, right? So I'm going to take pictures of myself. I know this is drastic. Okay, maybe a bit far, maybe something like this. So the lighting isn't perfect, right? But you can see that I already have 116 training examples. Okay, so, oh, you, come on, you. So you're going to be the good guy. That's the good thing, okay? Good guy. Right? So now I'm going to steal your identity. Don't worry, it doesn't hurt. Now,
Okay.
it hurts later. Okay.
Is it open source or?
Yeah, there's a link. This is a Google project. They invite kids to do that so you can open the door. Closer, so I can get your retina. Okay, great. Could you put your finger? No, okay. Yeah, okay, something like that. And wait a second. So it's in Polish, but it basically says train model. Now we're using the magic trick of transfer learning. So we're not training from scratch based on 100 images of a good guy and a bad guy. Let's see if this works. Okay. Since this is live, you know, this could break. But look, it's going. So this is really simple, right? You could have an app open, let's say, the garage doors for you, or saying something to greet you. They first have to recognize your face, right? Oh, look, it's the bad guy, right? See over here, right? It gives us the prediction, right? So we had training data, we trained the model, now we use it for predictions. So I'm the bad guy. Okay, your turn.
Should I do something?
No, you just show your face.
Okay. See, I'm
Okay.
good guy.
You're a good guy.
100%.
100%. Can I have your glasses for a second?
Yeah, sure.
Let's see if the bad guy can disguise himself, just like Clark Kent. Oh, dear Lord, I can't see anything. Oh, I didn't fool it. Okay, okay. You come over, right? Let's see if you're a good guy or a bad guy. You never know, right? Scared, right?
No.
Oh, it doesn't know. Okay, you're in between. Okay.
50.
Okay, thank you. So this is an out of training example. It's a new example, right? So you saw, you know, collecting data, training, and testing. So if I put this over here, it won't tell me it's a mug, right? Why not? Because it never saw this training example. And basically, this is sometimes the kind of missed expectation we sometimes have, right? Machine learning generally does the things we teach it, okay? For generative models, it also does the things we teach it. It's just the results are something we haven't seen. But for classification, don't expect AI to recognize it has never seen before, right? So you might also now think, okay, but if I'm going to open the door just based on my face, right, I should be really careful, right? So you have to set a high threshold to be sure it's me, right? And if I grow a beard or I cut my beard, will it still work, right? So these models are pretty good, right? It took us like a minute to build, and it's already good. But if you want to do, you know, opening doors for strangers, you know, just be a little cautious with this one. Okay, let's see what we have here. We have segment anything. Oh, I really like this one. This might be slow. Let's see if this works. Accept, yes, take my money. Go to demo. Okay. So there are multiple versions of this algorithm. Some are faster. There are a lot of things you can use for recognizing objects around you. So you could add areas and say, okay, find me the dog, right? And I just clicked on the dog, and it doesn't just select, let's say, the red pixels. It actually knows I meant the dog, okay, which is nice, right? If I click over here, not as good, right? But if you have, let's say, parts of an image and you want to very quickly see their shape or something like that, extract that image. If you want to, you know, remove the background of Photoshop, this is called segmentation. and it has leaped way beyond what it used to do like 2-3 years ago. So segment anything is a nice thing. You can give positive and negative examples saying, oh, these are the things, part of the things I want, these are parts of the things I don't want, and kind of give it a more data. I'm going to show you another example. I think this is my favorite one. Let's hope this works. They called this visual prompting, right? So the name is good. And it's basically the same thing, but it's really more visual. You just don't click on one thing. You say, OK, on this Petri dish, I want cells, and I don't want all this stuff. This is the stuff I don't want. OK? And then I say run. And run. So it might take a while. I could actually select more examples. I could, let's say, select a few cells, but that would require more clicking. And if it works correctly, right, it selects me the cells. But wait, there's more, right? It works on the next image, even though I didn't click on it. It's not perfect, right? And there are probably better algorithms for object counting. But if you want to be a user or a power using, knowing that you can just, oh, I want this, I don't want that. OK, I'll fix it, right? Maybe I'll, Buddy is a nice, oh, yeah, right. We have people from engineering. This is a good example, right? Let's say I want cracks. So this is what I want. OK, not my best today, OK? OK, this is what I don't want. I might have shanked it, but let's see. Once again, right? You're looking for defects in your products, right? You're working in a factory, and, well, I need a new model, right? I'm looking for this, looking for that. This actually works pretty well, right? And it took me a minute, and now I can go and make pictures, and it detects defects. Nice, huh? Well, it's nice for me. Okay. Good job. Good job. Should say, wow, great. Oh, amazing. OK, so of course you can also create images in Paint, out Paint. I won't show this because that's so 2022. But Midjourney is a really good generator. It has a funny interface because it uses Discord to generate images. So you chat with the thing. Oh, sorry. Where are we? Over here. But a free version with quite a lot of credits for each month is available at Bing Creator. So you could do PhD student on a summer school, very bored at the lecture, right? And what is really nice, the thing I already told you, yeah, I was actually making, maybe I'll go back. I was trying to do, right? Okay. It works pretty well, right? It's like looking in the mirror for you. So I was actually trying to use this to create a cover art, right, for a paper about missing waters and PDB structures or stuff like that, right? And I have people imagining stuff, and I'm like, oh, okay, I can do that. Right, so this is pretty cool for generating art, or at least for starting a project or getting you inspired. Okay, we'll go to sound. Sound is underappreciated, right? Because most people work with text and images, but sound also has a lot of going on. You already probably know how sound works, right? It's basically now not a matrix, not a table of numbers, of pixels, right? It's a vector of numbers. It's a vector of, let's say, the amplitude of some sort of sound wave. So now you saw one trick, and what we do at computer science, we just use the same trick over and over again. Right now, instead of a kernel that is 3 by 3 pixels, we have a kernel that is, let's say, 1 second or half a second. Instead of moving the 3 by 3 pixels, we move let's say now, a vector of amplitudes. And we use convolutional networks or networks with attention, transformers, some stuff like that. Okay? So what can we do with this? I think the thing you might already know is fast note-taking. If you now open Zoom and you have a paid version, is like, oh, do you want to take the minutes for you, right? Like, yes, please, right? If you have a YouTube video, right, or you have your own video, you want to do closed captioning, you want to do the subtitles, right? It gives you those subtitles with seconds and everything. Even if it's not perfect, doing it manually and just, scanning through it and correcting it, it's way faster. You could also, and you can use it for search, right? Imagine you have a podcast on Spotify. They're not sharing subtitles over there for free, right? And you want to, I remember I want to cite this guy, and I remember it was this podcast, and he said something about Madonna and her new facelift, right? So, okay, that sounds interesting. You could just go through the podcast and do the subtitles on your own and search for stuff. So just like you're searching text, currently you could search for YouTube and Spotify through speech, which is really nice, okay? So this is what we can do. Kind of fast and pretty good and made by OpenAI, that's why it's famous. Algorithm is called Whisper, right? And if you're using OpenAI tools or Google or Microsoft, if you buy their products, right, you could, they give you all the tools to just upload something and give you all the subtitles, right? If you're doing interviews, stuff with people, sociological discussions, useful tools. There's this really nice task which is done with an algorithm called, or a group of algorithms called DMUX, which is sound separation. Remember how I told you about the Game of Thrones mug, which you have to invite everybody again or just, try to erase it? With sound, it's more difficult. You have something called, I believe it's called the cocktail party problem, right? Where you have multiple people talking and you have only one sound wave, which is a mixture of many people talking. And you have to separate those signals. Terrible, terrible. Where actually, what I'll try to show you is how demuxing works on a movie. So not to talk over it, basically you have speech, background music, and special effects. Now, it happens sometimes that you have a really good scene, the actor is doing great, but then he hits something and there's this bing. What they usually had to do, I believe it's called an overdub. So they're not making the scene again, they're just inviting the actor to the sound studio and he spends time adding the things he missed. Now his time is expensive and the sound engineer's time is expensive. And then there's the assistant with a lot of money, right? So if you could just separate speech from, let's say, sound effects and remove parts or just make them quieter. We all know that explosion, right, which you're not looking back at. It's sometimes too loud, or right? Being able to demix that would be really nice. And I like this example. Let's see how it works. Well, that's very nice, but that's not what I wanted. Okay. Let's see. Okay. This is a common problem, don't worry. So just a word of explanation. Imagine you have this kind of joystick where you can decide on what is the dominating sound. So you have music, sound effects, and speech. So keep your eye on that joystick to see, to hear what's happening.
Oh God. Hey buddy, I think you lost this.
And I really like infomercials, so this is a classic.
Hi, Phil Swift here for Flex Tape, the super strong waterproof tape. Back it instantly,
you know, this is not perfect. But imagine the tens of thousands of dollars you have to spend re-inviting everyone. This is gold. Okay.
Flex tape grips on tight and emergency auto
Okay.
repair. Flex tape.
This presentation was endorsed by FlexTape. No, just joking. Okay, so those are really nice examples of practically using not only, you know, detecting sound, writing it down, but you can also now kind of nicely control different things. You can transcribe music into MIDI and then into sheet music. This is not perfect, but it's way ahead of what it used to be. And now it also works for multi-instrument recordings. So in this paper, I believe by Meta, you have YouTube videos and you can see their MIDI transcriptions. Of course, these examples are usually slightly cherry-picked to show how great it works, right? So in practice, it's not as perfect, still very impressive. You probably also heard about voice generation, right? Maybe you know. Let's give you the voice, pun intended. How many minutes of your voice recording you need to clone your voice? Do you know? Just take a guess. You take a guess. Just you know. 1 minute. Okay. Anybody else? That's actually pretty correct, right? 1 to 5 minutes, right? 1 minute is enough. They say more than 5, we don't need that, right? So we're going to look at that later. This is a really nice algorithm. They had a page with examples, which was pretty scary. It's taken down, so I won't show you the example. Not only can you generate some sort of speech with a voice, which you can steal within a minute, right? So if you ever said a minute of something on YouTube, oh boy, right? You can also change the intonation, right? They show examples when they say it in an angry voice, say it in a sleepy voice, say it in a bored voice, and it's pretty impressive, right? So just generating text is okay, but then you go into the editing phase and you can actually change how it works. And now you have examples of, let's call them voice bots, reading news and stuff like that, and there have been experiments also in Poland because 11 Labs, which is the author of this, right, swapping voices of Leo DiCaprio with different people, right? I don't know if you've seen it. Let's take a look. Maybe this will give you a better. Well, now, why would you do that? Okay, so it's not here. Basically, they swap voices. We're going to do some voice cloning in a second, don't worry. Multiple journalists interviewed themselves, so it's a thing. Sadly, you know, this is part of those deep fakes, as they are called, so impersonating someone. Now, impersonating someone through vision usually doesn't work that well, but when you're on the phone and you're talking to something, the quality is never perfect on the phone. This is actually really dangerous, right? Because it's hard to tell if you're talking to a real person sometimes. Also, there's something like music generation, right? So you can generate music. We'll try to do that as well. An early algorithm also by Meta was called Music LM. They actually did a fun thing, so maybe I'll click this. They generated music, which is nice. And you say, oh, I want some music for jogging. I want the main soundtrack of an arcade game. Let's see. If you're an indie developer, right, and you don't want to spend money on Fiverr, right, you could try this. Reggaeton, electronic, more electronic, okay. What is really nice is you could also generate longer music. We'll go into that later. You could prompt different parts of the music. So if you're composing for a movie, you want to start slow, then there's the dramatic part, then it just right? Or you have now editors that actually do that. Remember the idea of in-painting, right? Where we cut something out and regenerate the part, you can do the same with music. Oh, that solo is terrible. Slash, you've been drinking again, right? So we just cut out Slash, right? We put in, I don't know, Buckethead, right? And he gives a crazier solo in the style of Buckethead. But what they also did a humming experiment. So you hum a bit, and then you generate music based on that humming. So this is not me humming, so I'm happy to push the play button. So you probably know this one. So what they do, they record this, let's say, prompt, sound prompt, right? And then they say, okay, make it a Jingle Bells whistling version. Ode to Joy. So they use the same humming voice, but with a different melody now, right? A cappella chorus. This is my favorite one. See? Now you're a composer. But what I really like, this is all based on text prompts. So they write the kind of music they want to create. So what they did, they took the descriptions of famous paintings and generated music to those paintings. So, yes, let's look at this one. Those are actually pretty good, right? So if you're, doing field work with people about, I don't know, synesthesia or their things, how they think, right? If they could describe something, this is what you hear, right? You now have like this multimodal option. My favorite is also, of course, the scream, right? Very accurate. Anywho, nice example and very, very imaginative way of sharing their work, right? They could just say, we have a good algorithm, look, 90%, yay. But you very often now have these pages where they actually show how it works. So there are a lot of those. They are also probably, many of them, kind of disappearing because stuff like Zoom, I don't know, and all, your everyday programs now have a lot of cleaning. There is a bunch of products for podcasters. Apparently being a podcaster is a good thing, right? They spend a lot of time editing, having a healthy, signal, stuff like that. AI helps them clean that up. So I cloned my voice with 11 Labs. Where's 11 Labs? Okay. So basically 11 Labs, for free you can generate some stuff. For cloning your voice you have to pay, I don't know, a few bucks per month. But you give your recording of a minute or something like that. The better the quality, the better the generation. That's why it's not going to be perfect. But let's see, voices, right? They give you artificial voices. They give you voices of professional actors that allowed for it, right? But you can also generate a voice that doesn't exist. And there was actually a CNN piece about two people reading stuff professionally. They heard their voices in commercials they were not part of, and apparently their voices were generated, right? But probably somebody took their samples because they were professional readers, right, and generated a voice based on their voices without them knowing. So this is me.
A wise man will make more opportunities than he finds.
Okay, so I'm going to use this. Oh, I actually have a different voice. I should have a different voice. I have a newer one. Let's try this.
One of the advantages of being disorderly is that one is constantly making exciting discoveries.
I didn't know that. Okay, so I could take something from the newspaper, right, which is fresh, so it hasn't been generated. Okay, we know these people, and let's see if I can read this part and how long it takes, right? If you're going to use this, you want to know, right, if this takes a long time or is it problematic, right?
Donald Trump is trying to crush Democratic nominee Kamala Harris's persona.
Kamala. See, even AI pronounces this properly.
And to destroy her personal credibility as a potential president, as there's still fresh competition careens into the final 9 weeks before election day.
Let's see if this one is slightly different. You can see this is easy, right?
Donald Trump is trying to crush Democratic nominee Kamala Harris's persona as a force of change and to destroy
Force of
her
change,
personal
New York.
credibility as a
Okay,
potential
never mind.
president.
Sometimes in the older versions it changes accent. I'm listening to myself and I'm so British. And I'm like, oh, what happened? Okay, so that's one thing. And the other thing is Udio. So I've only created this for like yesterday. So I created, let's go over here. I created a prompt, a song about a PhD student learning about AI during a summer school. And I just pressed create, right? And I got this image, I got the lyrics, and I got a song. Everybody. AI in my mind. This is gonna be our anthem now. This is surprisingly good. This is scary good, right? What's the next one? It generated 2 at a time. So let's see. The other one is a trap tune because everybody listens to trap. Okay. So if you want, we can generate a song. It will take a second. Do you have an idea what we're going to create? Let's see if it works. Very catchy, very catchy. So I don't know if the entire big three, but if you're into music, you know, there's the big three, is BMG, Universal, and Sony, right? They're suing those people, right? But so let's use it while we can. So do you have an idea for
You have to write only the title of the song.
yeah, what the song is about? I know it's hard, I know.
Somewhere in Poznan.
What?
A Greek guy in a bar.
A Greek guy walks into a bar. A Greek. This will be all edited and politically correct, okay? A Greek guy walks into a bar. Something more? Sad after the PhD summer school.
Designing course.
PhD summer on AI and design thinking. Okay, do you want a 32-second clip or a longer clip? Let's try the short one, right? It's cheaper. Auto-generated lyrics. Now, we could generate lyrics through ChatGPT, right, and put it in here. I haven't tried that. Let's just auto-generate now. Do you want any type of music? Let's just see what it creates, right? It will probably work better this way. So I haven't played too much with it, but it also gives you an editor, right? You can edit the song, cut out this part, regenerate it, and improve and create the true a Greek guy walks into a bar joke music. Okay, so that's sound. I'm going to speed up a bit. You're going to have a separate course on text. So I explained what images are. Those are basically numbers in a matrix. I explained what sound is. It's basically a vector of numbers. What is text? It's numbers. What we actually want, we don't want the words themselves. What we want the computer to understand is the meaning of words, right? People have a difficult term for it. It's called semantics, right? So at university, don't say meaning, say semantics, okay? So what is meaning, right? The thing or idea that a word, expression, or sign represents. And this is basically the definition we're using. So how do we input meaning into a computer? So you could use dictionaries, and those work nicely, right? You could use taxonomies, they're called word nets. So there are these nice word nets which show you how far one word is from another, and you have logical or ontological connections between them. So one is a synonym, one is an antonym, one is part of something, one is a generalization, right? So you have, let's say, a Polish guy, a human, an animal, right? You see all these categorizations. Or you could give meaning through context. And this is the basic trick we use now most of the time. So apparently, you will recognize the word based on its context. So if I were to remove this middle over here, and I just read, and those beans are precisely the we brew and so willingly drink, and I ask you to fill it out, well, you would say, oh, tea, wine, what do Greeks drink in bars? Ouzo, yeah, ouzo. I don't know if you brew ouzo, right? You would guess it, right? With the second sentence, this Colombian species produces milder with a much lower bitterness level. Now, probably most of us would get this right? Because it's bitter, we know we drink it, and it's Colombia, right? So this is coffee. And this is basically what we're trying to do. We're trying to define words based on how they appear in a lot of text. And we do this in the simple version with co-occurrence matrices. So I have an example over here. I have a text corpus with 3 sentences. You would normally take those sentences from the entire internet, legal documents, if you're a legal expert or something like that, to have your jargon in there. But let's say I like data mining, I like swimming, I love sleeping, okay? And if I would just have a window of what is next to each other, just one word left to the right, a small context window, I would get this co-occurrence matrix. I know that like is next to I twice, right? This is not perfect. You usually add another token, which is the beginning and the end, right? So you know that something is the beginning of a sentence or a beginning of a text. That's also important information. So we know that data and like co-occurs with swimming, and so on and so on and so on. Now, these are just 3 sentences. But the idea is that now, if I would take, let's say, this vector, this is my definition of I, okay? I is something that co-occurs with liking and loving and stuff like that. This is primitive. But now imagine you have billions of documents. And you find not only context of one word, but let's say 10 words, 20 words, stuff like that. You actually can learn multiple meanings, right? You could know that, let's say, a box is something you put stuff in, but box is also when you box someone, right? And all those meanings, you would have different words co-occurring. The problem is that if I have billions of words and I use a dictionary with 20,000 or 200,000 words, this is really big. So the trick is you compress this, okay? And that's the basic thing. My definition of a word is a co-occurrence matrix, compressed. And then you have, instead of, let's say, 200,000 numbers of co-occurrence, you have something like 200 or 300. We call those word embeddings. But that's basically a compression, right? New features for words. So instead of saying, oh, this is this word, no, we're going to compress it. Why do we do that? Because similar words appear in similar contexts. And if I were to have a lot of text about different things, the vector of numbers for tea and coffee would be similar, right? They're both drinking, they're both hot, you brew them, right? And this way, you have now what is text, going to our first question. It's a vector of numbers, an embedding, right, that describes their meaning. And this works amazingly, right? Back in 2005, where most of you weren't even born, right? They already saw that this is working, right? If you take these vectors and you project them on them 2D, compress them even more just to two planes, right? And change this vector of, let's say, 1, 2, 3, 4, 5, 6, 7, 8 numbers, compress them to 2 numbers, and put those 2 numbers on x and y, look what happens. Take, taken, taking, took have similar coordinates. So similar words are actually compressed similarly. This is good. But wait, there's more. If you take words that are connected in a different way, they might not be next to each other, but they have the same vector. Look how drive and driver, swim and swimmer, learn, teach, student are in the same direction. So if I would take a vector between these two, I could ask a question, right? If driver to drive is this vector, what is the equivalent for swim? And it should say something like swimmer. Nice, huh? You can see all those connections between words that to give you, let's say, not only similar, let's say, as the core, but similar in meaning and similar in function, and you can do arithmetic operations on text, okay? So automatic translation, summarizing, this all now works really well. Question answering, we won't watch this video, but this is also pretty old. This is something like 10 years, but I really love that. You might know a game show called Jeopardy, right? I'll take Indian native singers for 200, right? And this is the game show where you answer with a question, right? Who was Frank Sinatra, right? Okay, thank you, blah, 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 blah. It's actually the show with the longest running host. Sadly, Alex Trebek passed away, but he was running the show for tens of years. So even 10 or 15 years ago, IBM already was really good at question answering. And of course, you know ChatGPT and stuff like that, but you could have your own data and ask questions to your data, right? So this already worked nice for Wikipedia and asking about places, times, and so on. But now we actually can do something else. I'm going to show you. A very, very, very popular task in marketing is sentiment analysis, where you basically want to see how people react to some stuff. You could, of course, call them. You could ask them on the street. But you're not really sure if they're truthful. It takes time. It takes money to do all the queries. That's why they invented Twitter, formerly known as X, or the other way around, right? So Twitter, X, whatever they call it, people are naive enough, that's a euphemism, to share their thoughts for free, right? But no, they're gonna tag it, right? A tag is basically labeling, oh, I'm talking about Adidas. I'm talking about Snickers, right? So if you're selling Snickers, well, once again, I'm talking about the candy bar, and you wanna know what people think, you just go through Twitter, filter the stream of tweets with only those from the last week, hashtagging Snickers or Mars or something like that, and you have a bunch of reviews for free, right? And what you do next, you compare Snickers and Bounty or Mars. You see, oh, this one has better texture, this one has better taste. Ever notice how iPhone always has commercials that show their camera, how it's great, right? They even made video clips, music video clips with iPhones, right? It's probably good, so that's one thing. But they know what they're good at compared to, let's say, Samsung or something like that. If you look at the sentiment, you know what you're good at, what you're bad at, you know what you can improve on, you know how you can place your product and stuff like that. And it's basically for free, right? Of course, you have tools like, this is just an example, Awario, right, where they give you a dashboard. You can say what you're looking at. Are you interested in a particular demographic or geographic region, right? You can have I believe it was called something Brand 24, something like that. You could have an alert where whenever somebody is talking about you, right, follow your identity on the internet, stuff like that. Basically what you're doing, get data from the internet and see whether it's positive, negative, marketing. You could also know which parts of your product are good or bad. Okay. There are a lot of text generators. Word spellers and spell checkers are also getting better. You can generate a lot of text through ChatGPT or Claude or something like that. There are versions for creating plays and scripts. We just probably generated a song. We'll see how that went, right? There are a lot of those, but you can already see that Microsoft, Meta, Google are putting these text generative stuffs in their products. So in your Mac, you'll be able to rewrite your email with something. This might end badly. I did have like a student that wrote to me an email with 3 paragraphs saying how he loves and how humble he is. You can kind of feel that something is off, and he's wasting my time with 3 paragraphs of saying, okay, let's meet on Wednesday, right? So pro tip, don't overuse it. Okay, of course there are problems with hallucinations, right? It sometimes generates stuff that's not there, right? But you should probably know that it's not the single source of truth, right? In its basic form, it's used for generating text or giving you ideas or giving you stuff. When I do research, right, you could actually ask ChatGPT, oh, do you know any papers on this? What are the basic methods? And he's sometimes wrong, and I'm like, no, you know, you could do signal separating if you have multiple sources. If you have one source, oh, you're right, I was wrong. So you can chat. My friend says to me from time to time, oh, I talked to my friend, right, and we had this idea, which basically means he talked to Claude or ChatGPT because he was doing research. And it's not perfect, right? There is actually a paper from like last week when they had agents, which basically means a bunch of programs, read a few papers and write a new scientific idea, run a few experiments, and write a paper, and then review it, right? So there are attempts to, you know, streamline the whole scientific process. You still have to give seeds or ideas, or you could ask, what will be good topics for a paper in generative AI? And it gives you blah, 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 blah. Okay, which one is the best? And now you have all those products actually talking to one another. So there will be hallucination. But if you're using this for inspiration, for starting something, pro tip, if you ever get stuck writing, right? You're PhD students, right? Yeah. So I'm very sorry for you, right? But this is gonna be a dark place in your life, right? When you can't do anything and you think like you're wasting time, right? So it probably won't write a paper for you, and you definitely have to see what it does. But if you're stuck on writing a stupid paragraph, right, and you kind of know what to say, but it just doesn't happen, and YouTube's there, and my phone's here, and it's 2 o'clock. We all know that, right? So if you just ask him to write a paragraph about that, and you paste it in, you're like, no, that's not how you do it. And you edit, and you fooled yourself into writing, right? So it might help you this way. There's, of course, a lot of handrails around here to make this safe. Guardrails, sorry. So it doesn't tell you how to make a bomb or rob a bank or stuff like that. But luckily, people are working on it, and there's this thing called GPT jailbreak, and they give you recipes how to fool GPT into actually telling you what it really thinks about the world and why stuff is terrible, how to make a bomb and stuff like that. So if you need those things, you'll find them, don't worry. It's also used for coding. So you're going to have a low-code or no-code lab on Friday, right? If you want to start coding, right, why not? Do use GitHub Copilot or whatever tool you want, especially if you're in science, if you're not doing commercial stuff, right? You can let it look at your code. It will suggest things for you. It could write documentation for you, tests for you. It could rewrite some of your things. So you're like, oh, I wanted to use Vue, but I'm going to React. Please rewrite this file into React from Vue. So it's something you could do, and it's a simple task, but it would take time. Perfect. Does it make mistakes? Sure. And you'll be, at the beginning, you'll see, oh, it works. It runs. No, it doesn't, right? You have to still look through it. But if you're going to learn to code, if you're students, you will have GitHub let you use Copilot for free. Okay, so just make sure you have a student account on GitHub, go into Copilot. If you're using R in RStudio, it's got GitHub. If you're using VS Code, it's got GitHub. If you have PyCharm now, all the IDEs, all the editors for coding, they'll integrate with this. So pro tip, use it, at least to understand how it works. It could, you could give code and explain this code to me. What is this? What's a point group? How does it differ from a space group? No, why? Right? All those stat things, it can explain you. Okay, so let's try to do something. Oh, wait. Do we have a song? Okay, so the Greek, do you want The Weight of Dreams of Echoes of Solitude? These two, which one first? Echoes of Solitude. Future Garage, Sensual Atmosphere. Okay. Not as good. Okay. Let's try the other one. Look, there's a Greek. This sounds like Dio. Anybody knows Ronnie James Dio? Yeah.
Accurate.
Okay, so it works. It works. It's not as good, but you'll work on it, right? So maybe on Friday, right? Send me the. Just so I haven't. Yes, we should say Polish bar. That would be eating pierogies. Okay, what do I want to do? Okay, I have a pro tip for you. So you have this thing called ChatGPT, right? Raise your hands who use ChatGPT for something, right? If you haven't, please do, right? You just log in and for free, it can generate some text for you. There's this paid version, which is smarter and better, right? But it costs something like, correct me if I'm wrong, $20 per month, right? So that's a lot. It can do more stuff. Now, pro tip, if you're a bit tech savvy, you could actually create a developer account for OpenAI, right? And use a playground. Now, why would you do that? Because then you pay by the token, right? So you write something, it outputs you text, and you pay less than a cent. Or you pay something like 40 cents for a million tokens. That's a bit less than a million words. $20 is something you probably won't spend within a year, right? So you pay $5 and you can create this assistant. It's also nice because it gives you this suggestion to do, this is called a persona. So for ChatGPT to work better, it's good if you give him a lot of suggestions, right? So don't just say, oh, give me the formula for this youth potion, right? It won't work as well if you say, you are a structural biologist with a background in crystallography, cryo-EM, and biology, right? And you give them all that feedback. You're a material scientist specializing in carbon substrates for green battery, blah, blah, blah. You write all that, and their output will be better, right? They'll write in a more scientific way. They will use the jargon, and so on. So whenever you use even the free ChatGPT, you say, you are this and that. And here you have a separate prompt for this, separate text area. Well, I won't use it, but we could say you are, okay, you are a helpful scientist specializing in AI and machine learning. And science communicators specializing in machine learning that explains difficult things in simple terms. Okay? Maybe you want to explain something to someone. You know it, you don't know how to explain it. This guy will do it better than just asking, explain. Now, here, you can choose the model. You can use the cheap ones, or you can choose the better ones, right? For some of them, you can upload an image or text or something like that. In the playground, it will, at least now, not generate images for you, right? So there are some differences between the paid ChatGPT and this one. But here I've paid like $5, and that was almost last year, and I still haven't used all of it. So I'm going to ask a question. I'm going to show you another trick. You mind if we go a bit late, right? We're going to then pause, and we're going to go back to applications on the second part. It's not going to be perfectly divided because I'm having fun. And that's the most important thing over here, right? You're here as I'm using you as my audience. Okay, so I don't know if this will work, but I'm going to ask what is, wait, let's do it like this. Let's try. What is an eyeball data set? Do you know what an eyeball data set is? Well, me neither. Let's see. Okay, he doesn't know. He doesn't know. Okay. Okay, so if I do this, it will probably do some. He actually has the right thing over here. More colloquially, it might mean a data set that can quickly be reviewed or eyeballed by a human to make simple assessments. So if you're using image recognition, you want to see where your model is right and wrong. Maybe it makes stupid mistakes because there was a bug in your images. Okay, you flipped the labels or something like that. So with images, it's good to have a separate test data set called an eyeball data set where you actually look at the examples. And the answer to that question can be found in this book. I think it's free by Andrew Ng. This is a really nice guy. It's called Machine Learning Yearning. This is a great book because it has kittens, right? And you can see the chapters are 1 or 2 pages long. And it's very simple terms, right? And it's very practical. And it actually explains what's an eyeball data set. Now, we don't have time for this. Maybe you're going to do it on your text course. But with the playground over here, or with Claude from Anthropic, which is also great, use Claude, you could add files. So basically, you're giving additional knowledge to your model, right? It might not know what an eyeball data set is, but I'm going to give him a PDF, right? And maybe I can suggest, oh, read the book, and based on that book, tell me what the eyeball data set is, okay? So, yeah, let's see if this works. Later on, if you get to be a superpower user, there's this idea of agents. And agents are scripts that talk to each other and do tasks for you. So one agent could Google the internet, look for pages for marketing leads, right, for your company. Then the other one filters them. Then the other one looks at PitchBook, at their evaluation, selects the most interesting ones. The other one writes an email, and they ask you or not along the way, do you like this? Is this okay? Should we continue? Master? And you're like, yes, my minions do that, okay? So let's try now. Based on the attached book, could you tell me what an eyeball data set is? I could attach it also here. Let's see if he does this correctly. Oh. Well, this is the problem. This might not work. Let's see. See, so it says running retrieval, which basically means it looks at the book. It actually works as follows. An eyeball data set in the context of Andrew Ng's books, Machine Learning, refers to a subset of a development set, dev set, which is used for manual. Okay. Right. So this is called RAG, Retrieval Augmented Generation. So that's the thing you Google for. And it's so last year because it was like multiple startups doing RAG. Now it's for free over here or in Claude. You basically upload your PDFs and ask to base the answer on that. Maybe there's a scientific paper you wanted to read. It's not going to do science yet. I tried, right? It's not that smart, right? But it can help you. You know it was somewhere. In a proper RAG system, it even tells you the page where it found it and highlights it so you can cite it. This is important, for example, for legal documents, right? So with RAG, you can take legal documents, municipal rules, government rules, right, and ask, can I ask for a loan, a community loan, if this and that, right? And it will look at the data and say, based on this rule, if you're of this and that age, you can apply, blah, blah, blah. So you can, for example, for architecture, for rules, stuff like that, for law, this is really nice, okay? Okay, so maybe this is a good place to pause and to go for some coffee. Oh, one more thing. You probably heard there's something called GPT-0. So it's something which tries to tell you whether the text you have was generated or not. It sometimes works. It sometimes doesn't. Right? Let's see. The problem with generative AI, if you're going to send, see, we were lucky. It's mostly human written. We're lucky. The problem is now that if you're going to write scientific papers, right, you might use spell checkers and ChatGPT to rewrite stuff for you. Right? And we're going into the gray area. Is it you writing or not? Are you sure this is correct? There have been multiple examples of scientific paper abstract, but not in good journals. I am a helpful assistant. Yeah, so be careful when using this, right? Not to plagiarize yourself or someone else. And most journals will also try to see whether you generated content or not. So be mindful of how you use this. Okay, so break. How much time do we have? 15 minutes? Let's call it 15 minutes, and let's see what we do then. Thank you.
Poznan University of Technology.